This is section 3.5. It's solving quadratic equations by using the square root property. Now, this is a little bit misleading because it's not just the square root property. The square root property is actually going to lead us to solving quadratic equations by completing the square. But in order to complete the square, you have to have a good understanding of how the square root property works. So it says given a real number k, if x squared equals k, then x is the square root of k or minus the square root of k, and the answer can be written as x equals plus or minus the square root of k. So notice that what they do is that for x squared equals k, we just take the square root of both sides, and when you do the square root of x squared is just x, and then you have two answers. Now, the reason why you have two answers is because early on when we talked about finding the roots of numbers, so if I found the root of 4, uh, then this really means what times what gives me 4. And I could take 2 times 2 to get 4, but I also could take -2 times -2 to give me 4. Same thing for 25. If I had 25, well, 5 times 5 would give me 25, and -5 times -5 also gives me 25. Okay, so I have two. So I have a plus and a minus. The plus is the principal root, and then we have the negative root. Okay, and so when you take the square root, normally we were only concerned with just the positive root. But here, excuse me, here we are going to be taking both. That's why your answers will always have, once you take the square root of x squared, you immediately write plus or minus, and then whatever you have the square root of. Now, in order for us to do this, we have to make sure that we isolate our x squared term. So 3x squared equals 12. My x squared term is not isolated. It's not by itself, but that's an easy fix. So all I have to do to get my x squared by itself is just divide both sides by 3. So then we get x squared equals 4. Now my x squared is isolated. So now I'm going to take the square root of both sides. And when I do this, this is where we got to be careful. The square root of x squared is just x equals. Immediately, we write our plus and minus, and then the square root of 4 is 2. And this is our solution. Okay. Sorry. We need to put this in solution set. Either like that, or you list them individually. +2 and a -2. Okay. All right. Now, number 2, I see that the x squared, there's not a number in front. However, it's not by itself because I have this plus 25, and I have to get rid of that plus 25. Well, that's easy. So we're just going to subtract the 25 from both sides. Now my x squared is by itself. So I'm going to take the square root of both sides. Now notice that you're taking the square root of a negative number. So the square root of x squared is x equals immediately plus or minus. Okay, well, the square root of 25 is 5, and the negative comes outside as an I. All right, so x equals plus or minus 5i. Okay. Golly, my hand is cramping up. So my writing is going to be worse. Okay. All right, now number 3. This is the one that throws people off. Now notice when we got our equation down to right here, x squared equals 4, before we took the square root of both sides, I had the square of this that was by itself. So what was I squaring here? I was squaring the x. So the x was a term that I'm squared. That's my perfect square. That's the term that's being squared. Here, x squared equals negative 25. I'm squaring the x, so it's by itself. And here, what are you squaring? We're squaring the x plus 7. So our squared term is by itself. Okay, so forget what's underneath here. Okay, notice that you have your squared term. It's by itself. I don't have a number in front like I did on number 3, on number 1, I mean. And I don't have something squared plus 5 like I did in number 2. Okay, so my squared term is by itself. All right, so since that's the case, what I'm going to do now is it's isolated. So we can take the square root of both sides. So on the left side, the square root and the square knock each other out. So we're left with x plus 7 equals, don't forget your plus and minus. And then how do we break apart the 8? Well, that would be 4 times 2. So the 4 comes out as a 2, and the other 2 has to stay inside. So that's 2 root 2. Now I need to solve for x. So I'm going to subtract 7 from both sides. This is how I leave my answer. Don't put the minus 7 back here behind the plus and minus term. Leave it at the front. Leave your plus and minus term at the end. Okay? And then for purposes of what Alex might want, I'm going to split this answer apart. And Alex might want you to split your answer apart like this. Okay, I would try to enter this in first, and if it accepts it, great. If not, then they probably want you to split it apart. Okay, so this would be minus 2 comma 2 inside the set, inside the braces, and then minus 5i plus 5i inside of the braces. Okay, so that's how the square root property works. Okay, now we have been talking a lot about perfect square trinomials and how they factor. We've been taking the square of the binomial, multiplying it out to get this, taking this, recognizing when we have a perfect square trinomial and factoring it. So what I want to remind you about is, how do you know if you have a perfect square trinomial? Well, you look at the first and the last terms. If the first and the last terms are perfect squares, then there is a good chance it's a perfect square trinomial. So here's what we're going to do. So I'm going to open up my set of parentheses, and I'm going to put the square on it. Now for the front term, what do you square to get an x squared? Well, that would be an x. And then what do you square to get the 25? That would be a 5. Now, I need to check if I get this 2ab term back. So 2 times a, which is going to be the x, times 5. This gives me 2 times 5 is 10 times x. I get my middle term back. Check. That's good. That's what I wanted. Then as long as I get my middle term back, I grab that sign, and that's what I put here for the square of my binomial. Okay. Now here, this is a perfect square. 9's a perfect square. So I'm going to open up my set of parentheses, put the square on the outside. What do I square to get x squared? So that's an x. What do I square to get the 9? That's a 3. Now I'm going to check the 2ab. So 2 times a, which is x, times 3. So 2x times 3 is 6x. Check. I got my middle term back. So I'm going to grab that sign, and that's the sign of my binomial, x minus 3 quantity squared. Okay? All right, and then they give us a note, x squared plus bx plus n is a perfect square trinomial if n is half of b squared. So what we're going to end up doing now is we are going to complete the square. And this is how we're going to do it. Okay? So notice here in this example, well, it's the same one as above. When they don't give us this number, we have to find it. So we take half of our b term. So in this case, it's 10, which is 5. And then we square that to get 25. So 25 is the value that completes the square. And that's why this ended up factoring into x plus 5 quantity squared. So essentially, what you're going to do is you are going to force a perfect square trinomial. And when you do that, there is no guesswork. You will get a perfect square trinomial. And you'll be able to immediately put it in your parentheses. Okay, so here we go. Determine the value of n that makes the polynomial a perfect square trinomial, and then factor. All right, so here's what we're going to do. So the pattern is that we take half of b and square it. So half of negative 12, and then we're going to square it. So half of negative 12 is negative 6. I square it to get 36. So 36 is the n. So that means we have x squared minus 12x plus 36. Okay. Now think about this for a second. We're going when you take half of whatever that number is and you square it, well, if I'm going to square a number, whether it's positive or negative, it's always going to come back positive, right? So look, I want you to come back here and pay attention, look real closely at what happens here. Look at the b term. This is the value that we're finding. And do you see how it's always positive? This is what we're taking, this middle term is what we're taking half of, and then we square it to get this term at the end. Okay? So x squared minus 12x plus 36, remember, you forced this to happen. So this is going to be an x, and then what did you square to get the 36? Well, we squared a negative 6. Okay? All right. Now, number 5. We're going to take half of our b term, which is 7, and then square it. Now, I know the temptation for you is going to be, oh, you know what? I don't want to deal with fractions. I'm going to get a decimal. No, you're not. You're going to deal with the fraction because you might, you don't ever want to get a number that you might end up rounding. So just leave it alone. Okay. And look, you're going to crunch this in your calculator anyways. At this point, if you don't remember your fraction rules, use your calculator. So 1/2 times 7, and then turn that into a fraction, which is 7/2. And then you're going to square 7/2. So then just take that and square it, and you get 49 over 4. 49 over 4. And that's the value that completes the square. And then now replace it and factor it. Okay, so now we have x squared plus 7x, and I know this is going to make you feel uncomfortable, plus 49 over 4. Now, remember, I told you, you made this happen. You turned this into a perfect square trinomial. So we square the x to get an x squared, and then what did you square to get the 49 over 4? Well, we squared a positive 7 halves. Okay. And I don't know if you can see what's going to happen, but do you see how this is a perfect square? And then once it's set equal to some other number, you take the square root of both sides, and we're going to be able to solve our quadratic. Okay. All right. Number 6. So we're going to take half of 5/4 and square it. So that's going to give us 5/8, and we're going to square it. Now, when you have fractions, you multiply straight across the top, straight across the bottom. And so when I square a fraction, it's just top times top over bottom times bottom. So this is 25 over 64. And this is the value that completes the square. Now, this one looks really bad, right? But we're not going to freak out because we made this happen. Okay, so this is going to factor. X goes up front. And then what did you square to get the 25 over 64? Well, we squared this positive 5/8. Okay. And that's how you complete the square. Okay. We found the value that completed the square. We made this into a perfect square trinomial. All right. Now, this is how it's all going to run down. To solve a quadratic equation by completing the square, we want to make sure that you start off with an equation that's quadratic in form, degree 2 polynomial, descending order set to 0. Okay. Step 1, we're going to divide both sides by a to make the leading coefficient 1. So if your quadratic has a number in front of the x squared term, you have to divide every term by that value so that you can make it 1. We can only complete the square if our leading coefficient is 1. Then we're going to move our constant to the other side. We want our variables on one side and move the constant to the other side. Then we complete the square. That's where we take half of your b term, square it. You're going to add that value to both sides. Okay. It's kind of easier to show you. So here's the quadratic. I have the leading coefficient is 1, so that's good. So that was step 1. Now, step 2 is that you move this minus 7 to the other side. So there it is. Step 3 is when we complete the square, we take half of the b term, which is -5. We squared it, and then we add that to both sides. And then step 4, we apply the square root property. So we factor the left side, use your calculator to get the fraction. Then you take the square root of both sides and then solve for x. Okay. Now, this is not difficult, but it's just a little tedious. Okay. But it's not difficult. Okay. So let's look at number 7. So here we go. So leading coefficient is 1. And let me back up. Quadratic in form, degree 2 polynomial, descending order set to 0. So it's quadratic in form. Leading coefficient is 1, so we're good. So now we're going to move our constant to the other side. So that's a -13. Okay. So now I'm going to complete the square. I'm going to take half, 1/2 of my b term, which is -6, and then I'm going to square it. So half of -6 is -3, and then I square it and get a 9. So 9 plus 9 plus 9. 9 is a value that completes the square. Okay, now I factor the left side. Now, what did you square to get the 9? Well, we squared a -3 equals -13 plus 9 is -4. Okay, now I'm going to take the square root of both sides. Okay, so we get x minus 3 equals immediately plus or minus. Now we have the square root of -4. Well, the square root of 4 is 2. The negative comes outside as an I. Okay, and then add 3 to both sides. So let me scoot this up a little bit. We're going to add 3 to both sides. So we get that x equals 3 plus or minus 2i. And then put this, now it's a complex number because of the I. So remember a plus bi, and then put it in set notation. Now, all of these are going to be nice under the condition of two things. Under the condition that your leading coefficient is 1 and that this, your b term, is even. So that when you take half of that number, you get a nice number. Okay? But when your b term is odd, that's when you end up having to deal with fractions. Okay. All right, so here we go for number 8. Quadratic in form, leading coefficient is 1. Good. So now we're going to move our constant to the other side. So that's a plus 9. Now we're going to complete the square. So I'm going to take half of 3 and square it. So half of 3, it's not going to, do not put 1.5. This is 3 halves. And then we square it. You square a fraction by multiplying top times top over bottom times bottom. So this is 9/4. So 9/4 is what completes the square. All right. Now, on the left side, we forced this to become a perfect square trinomial. So x squared gives me that. And then what did you square to get the 9/4? Well, we squared a positive 3 halves. Okay. Now, again, you have your calculators. So 9 plus 9 divided by 4, you get a decimal. Go to math, hit 1 to turn it into a fraction. And there it is, 45/4. Okay. All right. Once we've done that, now we're going to take the square root of both sides. So we have x plus 3 halves equals immediately plus or minus. Okay, so in the top, we're going to have the square root of 9 times the square root of 5 over the square root of 4. So I did 2 steps. First, I split them apart, and then I broke apart 45 into 9 and 5. So in the top, we're going to have 3 root 5 over 2. And then subtract the 3 halves from both sides. All right. And then set notation, -3/2 plus or minus 3√5 over 2. That's your answer. Okay. All right. Number 9. It's quadratic in form. We're going to move our constant to the other side, which looks like x squared plus or minus 8x. It's supposed to be plus. Okay. Now we're going to complete the square. So we're going to take half of our b term, which is 8, and square it. So half of 8 is 4 squared gives us 16. So 16 is what I add to both sides. Okay. On the left, we force that to happen. Equals 1 plus 16 is 17. Now, we use the square root property. And this is why we learned the square root property, so that you can finish it. You can finish the problem with it. So this is x plus 4 equals plus or minus the square root of 17. I can't break apart the square root of 17, so subtract the 4. Okay, and that's it. This is your answer. Please do not forget the plus and minus sign. When you take the square root of both sides, you're going to be on the right, you're going to be left with that plus or minus. Okay. Now 9. It is quadratic in form. However, I have a leading coefficient of 7. And I don't like that. We can't have that. So the first thing that we have to do is divide everybody by 7. Okay. So now this is going to give us x squared minus 2/7 x. I'm going to leave, go ahead and I'm going to move my c term to the other side. And 0 over 7 is just 0, so that's gone. Okay, -4/7, when I move it becomes positive. Okay, now here we go. I'm going to take half of 2/7, my b term, and then square it. So the 2's are going to knock each other out, so we're just left with 1 over 7. We're going to square it. So now we square a fraction, top times top over bottom times bottom. So it's 1 over 49. And that's what I add to both sides. Okay. And then the left side, that'll be the x. Now, what did you square? Let's see. Hang on a second. Oh, I didn't write it, but let me do this. I want to be consistent. Okay. So now, what did you square to get the 1 over 49? And we squared a -1/7. All right, now this part, number crunch. So 4 divided by 7 plus 1 divided by 49. It's an ugly decimal. Go to math, hit 1 to convert it to a fraction, 29 over 49. Okay, now we finish it. We're going to take the square root of both sides. So x minus 1/7 equals plus or minus. Now I have the square root of a quotient. So I'm going to split this up and say the square root of 29 over, well, the square root of 49 is just 7. And then add the 1/7 to both sides. And there's your answer. 1/7 plus or minus the square root of 29 over 7. Okay. And block these in. Okay. All right, number 10. So again, we start off, we do have an equation that's quadratic in form, but I have a leading coefficient of 6. That has to go away. So I'm going to divide everybody by 6. All right, so we have x squared minus 2x. Now we're going to go ahead and move that 17 over 6 to the other side. So that's negative 17/6. All right. Now, here we go. We're going to complete the square. I'm going to do this down here. So we're going to take 1/2 of our b term, which is negative 2, and square it. So half of negative 2 is negative 1, and we square it, which is 1. All right, so 1 is what completes the square. So on the left, it's just x minus 1. Now 1 you can rewrite as 6 over 6. So negative 17 plus 6 is negative 11 over 6. Okay. Now we're going to take the square root of both sides. Okay. So we get x minus 1 equals plus or minus. Then we have, I'm going to go ahead and split this up. Square root of 11 over square root 6 times I. Now, we have to rationalize this denominator. And the way that we're going to do this is I have to multiply the top and bottom by the denominator. Okay, so I'm going to multiply the top and the bottom by the square root of 6 because I need to make the radical go away. We're not allowed to have radicals in the denominator. And then here's the I. Okay, so now we get x minus 1 equals plus or minus. This is going to give us the square root of 66 over 6i. And then I need one more step. Add the 1 to both sides. And so there it is. 1 plus or minus the square root of 66 over 6i in set notation. Okay? All right. And then we won't worry about 11. I think I've given you enough examples to do. Okay. So that's how you use completing the square to solve a quadratic. Okay? All right. So that's it for this section.